So let's start with a bit of just looking at what are the things that you have to cover in this unit at school. And a lot of you guys have covered a lot of this already. So back in grade 10, you had the 4 laws and the 2 definitions. You had to learn how to simplify expressions and solve exponential equations and then understand like surds a little bit. This year, the exponents can be rational, which means they can be fractions. Your powers can be fractions. You also need to be able to solve equations with exponents that have fractional powers. So rational is just a number where it can be written in the form a over b. You also need to be able to do the standard operation with surds and then solve simple surd equations. So those are the 4 big things that you are focusing on in this topic, and that's how it fits in. So just give me a thumbs up if that looks like what you've been dealing with in class. Give me a thumbs down if you're like, oh, my teacher's been doing something else. Okay. So let's just start with a couple of multiple choice questions, which I'll skip through depending on how things go. So first question, which of the following is a power of 5? A, B, C, or D? So I see Tiana has locked in an answer. I want to see one from CM Tanda. CM Tanda. What did you get? So what we have here is the only one that is a power of 5 is 125, which is 5 to the power of 3. So 5 times 5 times 5. So the correct answer is D. Okay. Let's go on. This is very quick. So we're going to go very fast unless we need to slow down. I'm just checking you understand the laws. What's the answer to this one going to be? Okay, when the bases are the same, you simply add the powers. And if you add the powers, you should be getting A as your answer. All right. Give me a thumbs up if you're okay with that. Thumbs down if you are unsure. Okay. What about this one? What do you get as an answer to this one? This is called law number 2 for exponents. So the bases are the same, but you're subtracting the powers is what you should be thinking of, and you just get, which is B. Fantastic. That is looking, oh, I've made it angry. I've made the computer angry. Now, the answer isn't necessarily B, so it's just my computer won't, oh, there we go. What about this one? What is the answer to this multiple choice question? Okay, so you guys know this is law 3. If you've got a power and then another power, you just multiply those 2 powers together. You'll get 5 to the 12. You get A. Cool. I think we all know this one, but let's check. What is 7 to the power of 0? So anything to the power of 0 will just be 1, which is B. Okay, now I want to do a remix question of my own for the second definition. If I said to you, what is 7 to the minus 1 equal to? And the 3 options you have are 7 minus 7 1 over 7 or minus 1 over 7. Which of those four options are going to be the same as 7 to the minus 1? Oh, welcome, Kirsty. I think for now things are going fine. So what this question is checking is, do you understand how to change a negative exponent to a positive exponent? And so if you imagine that can be written like that, if you bring the 7 to the minus 1 below the line, it becomes positive. There's a definition that we learn about in this topic, which says the following. It says, if you have a negative power, if you move it below or if you move it up, it will change the sign of that power. So what do you need to know for this topic? You need to know 3 laws and 2 definitions, and you need to know them well. So that is the basics of this topic. I'm going to move on from this as long as you're all comfortable, but just give me a thumbs up if you are feeling confident and ready to take it up a notch. Okay. That one we've got already. Okay, here's a little bit something a bit more interesting. Can you simplify? Which of the 4 options do you think this one is? Which of the 4 options do you think this one is? Okay. What makes this one more difficult? I'd love to hear. I mean, it's a tiny group, so who can explain to me? Maybe just turn your mic on to just tell me. Or do I have to ask you to unmute? Maybe I just, yeah. What makes this one harder than the last one? What makes this one harder? It's as easy as just talk. Hey, how's it going?
I'm good, and you?
Very good, very good. What makes this trickier?
Because 20, when we make it like the product of its prime factors, it's 2 to the power 2 multiplied by 5.
Yeah. So the bases aren't the same. Hey, that's what makes it hard.
Yeah, they are not the same.
If I said this, if I said 20 is 5 times 4, would you agree with that statement? So what I
No,
was,
sir.
okay. So if I said this, if I said 5 times 4 to the power of 6 over 4 to the power of 3, would you agree that's the same question? It's just the 20 has been written not with its prime factors, but just some factors.
Yes, yes, sir.
Why did I choose 5 times 4?
Because the one of the bases correlates with the
Yeah,
denominator.
it's exactly that. It's that you wanted the basis to be the same in order to at least, simplify things. So what do
Yes,
you
sir.
think my next step is going to be after doing the,
We have to distribute the exponent, like,
yeah, exactly. The 6 has to be distributed into the brackets. And what am I going to get when I
yes,
do that?
5 to the power of 6 multiplied by multiplied by 4 to the power of 6. So
Okay,
over 4 to the power 3.
perfect. Now, what do you think is going to be my next step after that?
There are bases. There are bases on the numerator and the denominator, and they are the same. So we have
Yeah,
to minus the exponent. So it's gonna be 5 to the power 6 times 4 to the power 6 minus 3.
Perfect.
which will be
And then what
3
we're going to
over
get
6.
is this, basically. That's all we can get. Now, there's not anything more that we can do that I can see. So what I know is it can't be 5 to the 3 because we've already got 5 to the 6.
Yes,
It
sir.
can't be 5 to the 2. It can't be 16 to the 3. So it has to be
D.
that one,
Yes.
D.
Yeah.
So that's how these questions can get a bit harder, is if you have to do some manipulation now.
Yes, sir.
Thanks, Tanda. That was great.
My pleasure.
Let's see if we can find some more questions that are a bit more exciting. Okay. How about you guys do these first 5 questions? So there's 5 questions on the board. After you've done the first 3, in fact, you know what? Let's do the first 3 together, and then we'll do the last 2. So I'll give you 3 minutes to do 3 questions, and then I want someone to feed back to me what they get. We can compare answers. I'm going to get some water while you guys get going on that. So the first one and the second one are fairly straightforward, but the third one is where it gets a bit more exciting. So actually, it's not that much more exciting. The 7 has to be applied to the 1 and to the 2. So we get y to the 2, x to the 14 is what we get. Okay, let's take on number 4. I want to see, can you guys do number 4? And if that goes okay, we'll do number 5 as well. There's a couple of different ways you can do 4. We'll give it a go. And then, yeah, if you want to have a conversation or you want to clarify something, just speak freely. You're not on mute, so you're welcome to pop up.
Hi.
Hey, hey, how can I help?
Can I do question 4? But I'm not sure if it's
Okay,
right. So if it's not right, can't blame me
got it.
because yeah, school's
So
hard.
the main thing that is helpful is thinking through your question and then getting feedback. So even if you get it wrong, you're still going to learn as long as you get feedback. So let's tell me where you would start, Tiana.
Okay, so
Yeah,
I'd start with like the exponent there in the corner. That one did -3. And
yeah.
then I'd make it like 1/3 to like make it positive.
Okay. So you're saying you want to make this positive. How did you make it positive? Did
I
you
just
switch
said
the
one
things
over
around?
three.
Or you made it 1 over.
1/3 is exponent. 1/3 is an exponent. And then the 8 I also put in, it's like I put everything in brackets though, but then the 8 I made it 2 to the power of 3.
2 to the power of 3. Okay. So that 8 became 2 to the power of 3. And then you had a y to the minus 4. And then you had the 2. And then, this is quite a messy one, hey? And then what did you do? Oh, wait. So there's still this bit over here.
Yeah, then is it right if I make it like 1/3 or am I wrong?
Okay. I don't think so. What I was thinking is why don't we clean up instead of, like if we have to put the -3 inside, it takes a lot of work. Why don't we try and clean up what's going on in here first? And then maybe it'll make our life a bit easier. So if I
Yes.
wanted to make y to the -4 positive, what could I do here?
We take it to the top.
Yeah. So then would you be okay with me saying that that is the same question?
Yes.
Now that immediately looks a little bit less complicated. Hey,
Yes, it does.
now the next thing I was thinking is what if I wanted to simplify 2 over 8? Could I simplify that further, maybe?
1/4.
Yeah, 1 over 4. So that, I
4.
mean, and there are many ways to do this, but I think this can become 1 over 4. And then I was thinking, what would be very nice is if I could move the 4 from the bottom to the top. And then everything would be on one line. And that would be so nice. What has to happen if I bring the 4 to the top?
Will it become a negative?
Yeah. Now,
Yeah, negative exponent.
I want to suggest that this is so much nicer to deal with because I don't have a fraction anymore. Do you think, and there are different ways of doing this. There's another way I could have done this, but I like the idea of cleaning the house first and then moving inside. What do you think we're going to do next?
We're gonna times the exponent outside with all of the ones inside.
Yeah, so this -3 is going to get applied to all of that. And so then I'm going to get -1 times -3 is to the positive 3. And then I'm going to get -3 times 3 is -9. And then that is going to be y to the -12. Okay, now
So
when we give our answers, we like to leave them as positive powers. So what can I do now to make sure these end up as positive powers?
so then we'll say 4 to the power of 3 over x to the power of 9 and y to the power of 12.
Perfect. And that's about as simple as you can get. Some people would say maybe you should make 4 to the 364, but to be honest, that's as simple as you get. Now, that was a tough one. So I want to say, look, the technique that we used was just to clean up the middle and then go from there. Okay, let's give number 5 a go. And then maybe Siamtanda can give us some help on that one. But thank you, Tiana. That was lovely. So I think what I would suggest doing is just maybe multiplying out some of these powers. Or you could write them the long way as well if you want. You could just say, look, it says squared. So that means that times that, and that times that times that. If you want to go the long way, or the short way would be to say, look, you have both of these, and the 2 needs to be applied to both of them. So you get the thing that will catch a lot of people is the -3 gets squared. And so I want to know, what is -3 squared going to give you? Let's go to Siamtanda. I'm going to ask you to unmute
Yeah.
there. Yeah.
So -3 in brackets squared is 9. Positive
9. Yep. And then what's a squared going to be?
8 to the power 4.
Yeah. And then this one.
8.
Okay. And then this one is 8 to the 3.
8 to the
So
power.
what's my final answer going to be?
72 a to the power 7.
Perfect. And if you went the long way, like where I literally just wrote it out every single time, you'll notice you get 72, and then a squared, a to the 4, a to the 5, a to the 6, a to the 7. So both those ways would be correct.
Yes.
All right. Let's move on to just doing these 4 questions, and then we're going to have a break. Okay, so we've got 2 minutes till halftime, and then we're going to have a break. I want to see, can you do these 5 questions even, these 5 questions for me to check your knowledge of exponents and how to use the laws. And then just say done in the chat when you're done with those 5 questions. And we'll have a look at the answers. Okay, so I put the answers for 1 to 3, and I want you to tell me when you're done with trying to do 4 and 5. Okay. Let's see if you guys agreed with this. So this is the way I would do it. In this case, you can't really clean this up anymore inside. It looks the same. So I would say there's phantom ones here and here. And I'm going to then apply these three at 3, but not just there. I'm going to apply it here as well. So I get 2 to the 3 times x squared, and then that's going to be times 3. And then here, 3 to the 3, and then this is going to be 3 times 3. So we then get 8 for that and 27 for that. And then we get x to the 6, and we get y to the 9 for number 4. Give me a thumbs up if you got that for number 4. Okay. And then let's just do number 5 as well. So just get rid of that for a second. So with 5, it's just this -3 problem again. Like if you do it the long way, what this is saying is, look, just take this and do it twice. So that will be the long way. If you do it the short way, we're going to say, look, -3 gets raised to the power of 2. And then I've also got y to the 3 to the power of 2. -3 squared is 9. And then this gives you y to the 6. And if you do it the long way, you can see that the -3 and the -3 give you the 9. And then the y to the 3 times the y to the 3 gives you my y to the 6. Give me a thumbs up if that's good. Okay. So we've done half an hour of maths now, and our brain can't really handle more like this unless we reset it. And so what we're going to do to reset it is we are going to stand up together. If you can leave your camera on, that would be awesome, so I can see your lovely faces. And we're going to do some exercise together just to reset our brain. And so what I want to do is, what we'll do is I want you to just stand up and just have a little stretch. And if you can turn your cameras on, I know it's a bit of a strange one, but oh, it's so nice to see the student faces. I want you to stand up with me, no sitting down. And I want you to just stand up and stretch for a moment with me. Your body's been sitting for half an hour. It doesn't want to stay sitting. If you want your brain to take care of you, you need to take care of your brain. Okay. Now, what I want to do is make sure there's a space around you that you're not going to whack anything. So it's clear. And what you're going to do is you're going to do some jumping jacks with me. And the reason we do this is it gets our heart rate up and it makes sure that our brain forgets about maths. It just says maths is not a priority. Right now, I'm doing jumping jacks. So a jumping jack goes like this. And that's all we have to do. And we're going to do 10 of those. So we're going to start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9. Right. And let's do 5 more. 1, 2, 3, 4, 5. And your body should have been thinking about surviving that. And so I hope that your brain got you. Just forget about learning maths for a second. And it felt a little bit like this guy. Let's have a look. And it was just worried about just having some fun for a moment. Let me know in the chat, how did that feel? Did you guys feel, do you feel like your heart rate is up a little bit? And do you feel like you forgot about maths for a bit? Let me know in the chat, or just unmute yourself and let me know. I'm a big believer in making students do a little bit of exercise between breaks. I really feel like it makes a big difference. Yeah, sort of, yeah. No, it's just, I really feel like in my classes too, like I really like students to move around, because the moment the blood is pumping, they can unwind a little bit. And so I find that it really helps bring productivity to the next part of the session. Okay, let's do a little puzzle together. So here's the puzzle. You need to figure out what a red sweet plus a purple sweet times a blue sweet is. Hang in there, Tiana. It's the beginning of the year, so you can join. You should, at your school, you should join up with a maybe like the aerobics class or cross, or maybe athletics. You can do that. It's always good to join something at school. So where do we start with a puzzle like this? Where should we start? Row number 1, 2 unknowns. So I don't really know what's going on there. I think I would start in this row. What does a blue suite have to be equal to? So red is 2, blue is 3. Yes. So this has to be 3. All of these have to be 3. And then if that is 3, that makes this 6, which means this has to be 2, but there's 1 and 1. Well, let's make that a different color. So that's 1 and 1. So what does purple have to be then? What does purple have to be? Well, there's only one unknown. Something times something is 16. So actually, purple has to be 4. Yeah. So now we have to use BODMAS or PEMDAS to help us figure out this bottom bit. What is the final answer going to be? So 4, so 1 plus 4 times 3, you have to do the multiplication first because of BODMAS. So what are we going to get? It's going to be 13. Because BODMAS says do multiplication before you do addition. Okay, I feel like I've had a bit of a relax in my body. We had a bit of fun with the puzzle. And so I'm ready to head back to some exponents. How are you feeling? I hope that you're feeling a bit refreshed there. So I want you to try and do these next 2 questions. And it says, simplify where possible and write the answer with positive exponents. You're sweating, sir. Is it your brain working overtime there? Or was it the jumping jacks? Okay, let's do number 1 and then number 2, or A and then B. Give these 2 a go, and they want you to leave it with positive exponents. If you're done with A, just put A, done. If you're done with B, just put B, done in the chat. Oh, I saw Bile is joining us. Okay. I think there's a phantom 1 there and a phantom 1 there. Welcome, Ngobile. It is good to have you with us. We've just had our halftime break, and we're starting off in the second part of the lesson, and we are applying law 3, because that has to be applied to all these. What is my final answer going to be for A? I think what I'm looking for is I'm looking for things that have the same base. So if you have the same base, I can group you together, and then these are just numbers, so they can hang out in front. And so what I would then do, I guess this is 8. This is 25. And then what do we do? We have, let's use a dot. So x to the 9 times, I'm so used to using that for, so x to the 10, y to the 3. So 8 times 25 is 200. And then if the bases are the same here, we're going to add the powers. And here we're going to add the powers again. So we're going to get 11. Give me a thumbs up if you followed how I did this one. 4A. Give me a thumbs down or a meh, like happy sort of meh face if I lost you, or if you'd like to ask a question, just raise your hand and I'll come along and we'll have a chat. So really the 3 steps were multiplying out the brackets, simplifying, and then moving things with the same base next to each other. So let's see if you can do this next one here, if there are no questions about A. And if you think there's a tip that somebody else in class could use, then put your tip. What would your tip to them be for B? My tip would be rewrite this in a way that it's easier to see that it's division. That would be my tip. What would we have to do next after that? Tiana, what do you think? What do you, and there's actually multiple ways to deal with this, but I think what gets your attention? Or Bile, what do you think?
So I think
Yes.
we should just simplify the 9 and the 27. Then we say 1/3.
Okay, so you went for the numbers first, and you said this goes into itself once and there 3 times, yeah?
And then
And how do you deal with this?
the variables, I'll just swap it around. In the x to the power of 3 will come on top, and the x to the power of 2 will come in the bottom.
So you're saying you brought the x to the -3 to the top. So you basically bring that to the top, but it becomes +3. And then did you take the -2 down?
Yeah.
Okay, so then you got this. Okay, then from there, what did you do?
From here, so I said 1/3.
Yeah.
Yeah, 1/3. And then I say the 3 minus the 2, and then it's just 1 x alone.
So the bases are the same. So you could just go, look, it's an x, and then let me go 3 minus 2. So I get 1/3 x as my final answer. Yeah, I see Siam Tanda, I see your hand is up. Thank you, Tiana. That was great. What is your question?
So is it fine if I did it in a different way? Because I went
Perfectly fine. Tell me how you did it.
I said 9 over x squared. I started with the exponent.
Okay. So you said you started with this bit, and what did you do with the 9?
I first simplified.
Okay.
Then I said 9 can go into 27, so it's 1/3.
Okay.
Then I changed the exponents, and the x to the power -2 goes below, then x to the power -3 goes above.
Aha. So you
Then
let me just quickly catch up with you. So you did that?
Yes, sir.
Okay, and then?
Then I saw that the bases are the same, so I said x is to the power of 3 minus 2. Then I got 1 over 3x.
Okay, so then you've got 1 over 3x to the 1, but you're quite right. You can rewrite this because x can always be written over 1. And so you can write this as x over 3. That would be the same thing
Yes,
as
sir.
1 over 3, or third x. Those are all equivalent ways of writing the same thing.
Okay, thank you, sir.
Cool. All right, nicely done. Okay. If I said to you, okay, I'll deal with, let's have a look at this one. So I want you to do for me B. I want you to try and do B. And then D looks a little bit different, but have a crack at that. And if you're unsure about something, ask me. But what do you get if, let's try and simplify these two. Let's try and simplify these two. I tell my students in class, whenever you see a divide sign with exponents, just rewrite it so it's visually easier to see. Because students find it hard to understand the division when it's not written like this in this section. So really encourage you, whenever there's a division, take the time to rewrite it so that, yeah, that this can go from there. I'll be there. Just give me a thumbs up if you're hearing me okay. And you can see the screen okay. I just want to make sure that you are technically okay. There's a little thumbs up you can use in them. Okay, so for B, 12 over minus 4 is minus 3. X to the 5 over x squared is going to be x 5 minus 2. And then y is going to be 8 minus 4. So we should get that as our final answer. And then for D, Siamtanda, what does it mean with this power of 4? One of the things for grade 11 is we start to explore the relationship between the square root brackets and powers and fractional powers. So maybe give me a little bit, what have you learned in class about when it says the square root of 4? What does that even mean?
Square root of 4 means we divide by 4. It depends on the square root, what number is there.
Okay, so would you have learned that actually I could replace this with this? This means the same thing.
As 1
So,
over 4, yes.
yeah, 1 over 4. Or when you multiply, so basically, if you see the fourth root of something, it's the same as raising it to the power of a quarter. So sometimes when you see it as a law, it's a surd law, it looks something like that. So the
Yes.
nth root of a is the same as a to the power of 1 over n.
Yes, sir.
Okay, so we'll carry on with that a little bit more in later lessons. From that point, what did you do?
I basically distributed the 1 over 4. So I said 16, 1 over 4. Then
Yeah.
A is 16 over 4, meaning that it's 4.
Okay, so you've got 16 to the power of a quarter, and then you've got 16 over 1 times 1 over 4. You're quite right. That's going to be 16 over 4. But now if we want to simplify this, I want to know, what can we do about the 16 to the power of a quarter?
We can make it a factor. I think
Yeah.
I make so it's gonna be 4/2 or 2/4, sir.
Yeah. So what you can do is you can take the 16 and break it down into 2. Now, why did I choose 2 and not like 4 as a factor? Why did I choose 2? What was so helpful about choosing 2 in this question?
To simplify.
Yeah.
Simplify further.
So it had a 4. And so I wanted a 4 so that it could knock out the quarter.
Yes.
So basically, when you multiply, let me move up. When you multiply these two together,
Yes.
4/1 times a quarter, and then this is sitting over here. These 4s are going to cancel out, or you get 4/4, which means the final answer is going to be that, which is just 2a to the 4.
Yes, sir.
Now, I took a long way to do that because I wanted to explore those. But give me a thumbs up in the chat if you've followed my logic. Okay. So let's say the last question for today. I think we've done enough for today. For our first day, I want you to calculate what the value of that is. And then we are going to call it a day for today. How would we simplify that? Where would you start? Where would you start? Would you start over here with the tick, by the cross, or by the circle? Where would you start your simplifying? I agree, Simtada, so much. You make your life difficult if you don't start on the inside. So I would leave the -3 to the end and then just deal what's in here. So the square root of 9a to the 12. Now, there's actually a quicker way of doing this, is to say, look, the square root of 9 is 3. The square root of a to the 12 is just a to the 6, or divide the power by 2. So this one over here can be handled in just one little deduction. Now, there's a plus sign, and then you've got -2a to the 3. Now, depending on how confident you are, you want to distribute that. You could do this in one step. But we get that. And then the -3 is hanging outside. So now, -2 squared is going to be 4a to the 6. That is going to be 3a to the 6. And then there's this -3 that's hanging outside. Another way of thinking of it is -2 squared is 4, a to the 3 squared is a to the 6. What is my final answer going to be? What is my final answer going to be? There's something familiar about 4a to the 6 and 3a to the 6. What do I need to do with these two? Yeah. What do you do, Simtana? What do you think?
The answer is going to be -21 a to the power 6.
You're perfectly right. But before, so you've got it perfect. How did you know what to do with these two over here, though? Because they're being added. What law did you use?
They are like terms, so I added them together,
Yeah.
and they gave me 7a to the power -6.
The magic word I was looking for, Simtanda, was like terms. You recognized The base was the same, the power was the same. So you got 4 of these and 3 of these. So in total, you have 7 of them. And then your last step is you take minus 3 times 7, and you get minus 21, 8 to the 6.
Yes.
And so it ends. Okay, in the next lesson, we will be going into more detail and harder questions around exponents, but I think we had a lovely base from today. We went over the main 3 laws and the 2 definitions, and we started to apply them to specific questions. And so in the next lesson, what I'm going to do, I'll show you some of the, okay, that's too easy. These are all, we'll do some of those. We'll start to look at questions like this, where we have a whole bunch of exponents together. Maybe a question like this, where we have to break it down, and where we have to simplify these more complex expressions. And so that's where we're going to go in the next lesson. All right, everyone, I'm going to call it a night for tonight. Let me know in the chat, how did it feel? Was it easy to get into class today? But yeah, otherwise, we're going to give me a wave as you leave class.